is we did the derivative of lns yesterday, and whenever we did the derivative of a ln or a log, what you did is you wrote what was beside it in the base, multiplied by ln of the base, and then put the derivative in the numerator. Correct? That's what we did yesterday the whole time. Wrote what was beside it in the denominator, multiplied by ln of the base. If it was ln e, it just goes away, and then the derivative of what's beside in the numerator. So for these ones, we just have a y. So this is not only a ln derivative, it's also an implicit derivative because we have an x and a y. Correct? So we're going to get a y prime. So here we have the derivative. So we write x in the bottom. Ln of the base. What's the base when it's a ln? E, because it's log base e. And the derivative of x is 1. And then that cancels off, right? Then plus derivative of ln y. Y goes in the denominator. And then ln of the base, ln e again. And the derivative of y on the top. 1 y prime, yeah. Or you could do dy over dx, but it starts getting real ugly when, in this case, when you use the dy over dx. Equals, and the derivative of 2x is 2. So we've done all the ln stuff. The ln derivative differentiating is done, correct? Now we're doing implicit. What was the step for implicit? You want to get y prime by itself. If there's more than one y prime, you get them to the left. Yep. And then everything else to the right, take out the y prime. But this one only has one y prime, correct? You just have to move everything but it to the other side. So we're going to subtract the 1 over x. So we're going to get y prime over y equals 2 minus 1 over x. And then what do I have to do? Multiply by y. So I'm going to get y prime equals y, bracket 2 minus 1 over x. Done. In this case, if I wanted to replace the y, I would have to get these together, convert it to a log base e, convert it to exponential, and get y by itself. So you should really thank them that they leave it in that form. Because to isolate y on the top, you'd have to go ln xy, because they have the same base, you can put them together by multiplication. Then you'd have to go e to the 2x equals xy, and then divide by x to get y by itself, to put it in. So it's quite the fun endeavor. Okay. I left C till today because it's an absolute value function, and when you have an absolute value function, you actually have a piecewise function. Because in grade 11, you were taught about piecewise functions of absolute functions. So when you take the absolute of something, it's plus of that and minus of that, correct? Because the absolute value of negative 3 is 3, the absolute value of 3 is 3, correct? It's just the distance from 0. So whenever you get an absolute value, you can actually do a piecewise function of ln negative x and ln x. The catch is a negative x exists on the left of x equals 0, right? Like if you actually type this into your calculator, the absolute value of x, it looks like this. So this is negative x because it's the equation of negative x, and it only exists if x is less than or equal to 0. This arm is on the right, and it only exists if x is greater than or equal to 0. And now you would just differentiate them separately. And if they had come up with the same derivative, then that's the derivative. Remember how to check on differentiability is if you do the left and you do the right and they come to the same thing, get the same thing. So if we do the derivative of ln negative x, what do we get? We're going to get negative x on the bottom, ln e, which is 1, and then 1 on the top. So we get y prime equals 1 over x. We agree? We know ln x is already 1 over x, but we'll prove it anyways. If we go y equals ln x, y prime, get x on the bottom, the derivative of x on the top, and they match, right? So, sorry, y prime of this is 1 over x. Then here's a whole bunch of fun things to do.
That's okay. So you said this was a 5-credit course. Could you just get like 3 of them?
No.
And do less homework?
It's not like InfoPro or something. It's not the entire textbook. And you little whiners, just so you know, I'm going to record this. I do the answer key for every single one, so whatever questions you do, I do.
So I'm doing this here, or you're...
I'm doing them now. Because we just swapped the textbook out
You know what?
through COVID. We used to use the white one. So every night you do homework, I do homework. I just may be able to complete it faster, but that's fine. Same thing. You also have the solutions to my homework.
I bet you use But you told me not to use those until I got it.
To try it out first, yes. But then when you get stuck, you have somewhere to look. I have just me.
That's
Oh, that's 20-1. Okay, so this should be y equals in front of here. There's a typo. Okay, when you see something like this, you don't go, oh goodness, I have an f prime that I'm going to have to do product rule with chain rule in it. If you attempt to do that, and you're like, she would do that to us? She wouldn't. She would. You don't do it that way. If you do it that way, if you're going to ask for 4 sheets of paper, I would be like, stop the madness. Okay? So if you see a product rule for either your f or your g in a quotient, do you see that? Like this one would have a product rule to get my f prime, because the top is f, the bottom is g. Do not do it that way. Do not use quotient rules. Okay? You're going to use logarithmic differentiation, which seems, it's like a lot of writing, but it's not hard. Okay? So we're going to use a little bit of knowledge from 30-1 to help us out. So whenever you see this, your first step is going to be to ln both sides. So we're going to do logarithmic differentiation. Your first step is going to be to ln both sides. Because you can't just randomly add something to one side of an equation without adding it to the other. You completely change the equation. So when you see something where your f prime or your g prime is a product rule, think, don't do it this way. Think logarithmic differentiation. So your first step is to ln both sides. So I'm going to go ln y equals ln that. Like I said, it's quite a bit of work to write out, but it is not hard. So I lose people at this step, and I don't know how. I literally just wrote ln and a ln. Okay? It's just the exact same as what was up there. I just put a ln in front of it. So if you look at your paper, you'll be able to see. Yeah, it's a 3. On the 2x minus 3, it's cubed. Cosine. 3, 2, 1. 1, 2, 3. What the heck is bothering me? 3, 2, 1. 1, 2, okay, so we were taught with logs. This is the second step. You're going to use a log law. So if you look up here and you're like, oh, no, it's not like ridiculous. So when we have two things multiplied, we can take them out as what? Additions. As a ln is just log base e, so it's the same thing.
Oh, and so the
Log base 6 it works, log base 10 it works, log base m it works, log base a it works, log base e it works, right?
okay.
So our second step is to use our log laws. Actually, our second/third. We're using log laws from 30. Log laws, not lob laws. That's a store. Lob laws? Oh, that's, yeah, nope. I don't even know what that is. Okay, so ln y equals, now anything in the numerator got a +1 in front, anything in the denominator got a -1 in front. Remember that was the rules that we used in 30? So we're going to go ln 2x minus 3 cubed, and then we're going to go plus because it's in the numerator. And I'm going to change this to 2x4 plus 1 to the what? A half. So I'm going to go plus ln 2x4 plus 1 to the half. And then because this is in the denominator, I'm going to go minus ln of x. So we're basically just expanding the log base e, the ln. We agree from grade 12? What was the next step we did when we expanded it out? Do you remember?
You can divide.
Drop the exponent in front. Because if I just lay a coefficient in front of any derivative, what does it do? It just stays, correct? If I leave it as a 3 up there or a half up there, I'm going to have to do what? I have to chain rule embedded in a ln. That's pretty ugly, correct? So if I take all of these, number 2, log laws, 2 is the multiplication division, 3 is power rule. So it's a different one compared to what you did there, but that's okay, as in calculus. So these are all going to drop in front, so that I get rid of the chain rule problem. Because remember, only with logs, you can't just do this like, someone's like, well, if I have 2x plus 3 cubed, I can just take the 3 and drop it in front. Now I don't have chain rule. That is not a real rule. Don't leave here thinking that that's real. The only reason why the exponent can drop in front is because there's a log, right? It's power rule of a log. It's over here. It shows it to you. It says log b mn equals n log b m. It only works with a log. This is a log base e. It works, correct? But you can't go now to every chain rule and be like, I dropped 3 in front. Now I have a coefficient. Life is good. I see this happen after this moment. Don't leave this moment. Okay. So our numbers can drop in front. So that's step 3. Ln y equals 3 ln 2x minus 3 plus a half ln 2x4 plus 1 minus ln x. And now I just do derivatives. Now I have it in a form of a whole bunch of what we just did. There's just 4 of them now. 4 separate ln derivatives. If you look at it that way, it's not hard. So let's look at this one first. How do I do the derivative of ln of y? Y in the bottom, then ln e. And I know this is useless, but when it's not ln and it's log something, you won't forget this. At least keep practicing it, right? And then a y prime on the top. Okay, done that one. This one, the 3 just sits out front. I'm going to write it as a 3 over 1. And then I have to do the ln, or the derivative of ln. Remember, coefficients can just sit there. We've discussed this over and over and over. So what do we do? How do we do the derivative of a ln 2x minus 3? We go 2x minus 3, multiply it by ln e in this case. All of these are always going to go away. And then the derivative of 2x minus 3 is? 2. Done that one. Let's go this one. 1/2. What's the derivative of ln 2x to the 4 plus 1?
2x plus 4 to the first to the 4 plus 1 on e, which goes away to the ax 3.
Yes, 8x on the top. And then what's the derivative of ln x? 1 over x. And why is it that? Because it's x ln e, which goes away, I don't want. Very close to being done. So we're going to get y prime over y equals, so I'm going to get a 6 on the top over that, over 2x minus 3. Plus, now this half and this 8 can cancel, and this is a 4, so I'm going to get 4x cubed over 2x4 plus 1 minus 1 over x. The great thing is they'll never put those together. They're not going to make you make a common denominator. They're not going to make you put them together. There is one last step, though. Multiply the y over, because it's not in y prime yet. Now, you can either do this in 1 or 2 steps. If you multiply just the y up, you're going to get, I'm going to erase this because I don't remember, but say I multiply the y up. I'm making this big for a reason. And then I have 6 over 2x minus 3. They'll never leave it like this, with just the y beside for logarithmic differentiation, because they give you the equation in y equals, correct? Like the original equation, scroll up, was in y equals that. We agree? So they'll always take this y and say, nope. And then they'll just input that ugly fraction in the front. So they'll go 2x minus 3 cubed. And I know you guys are freaking out, but you're literally just rewriting the y. So I
Why do you
believe,
insist on making it ugly?
I believe in you. It's not ugly, it's all X's.
It is ugly, though. It's.
Well, they could make you make it nicer. They could make you make a common denominator over here and then put them together, which would be really ugly.
They're just so extra.
Can you explain that last step?
I just input Y. In
We
for
are
Y.
multiplying y over,
And then I put what Y equals in for Y. So I brought the Y up, and then I actually multiplied by Y, but then I said, well, can't put Y, so I put what Y actually equals, which is just the original equation. And you're done. Don't worry about this one. I won't make you do that one. But there's way more below. It's just one. Okay. I want you to try this one. And go. So we're going to ln both sides. So we get ln y equals, and most people can do this if I give you the steps, but most people don't practice enough of them before the test, and then they get stuck. And they're like, I remember there's stuff, and I have to do things. But what those things are, I do not know. Okay. So we ln both sides. Weird. Okay, then we use our log laws. So the first log law is the multiplication and division one. So we're going to get ln x squared plus ln 5x plus 1 to the half minus ln 3x minus 2 cubed. Okay, then our second one is to use the power rule of logs and drop the number in front. So if you're like, man, she's nasty, she's making me do like a chain rule in this, how horrible is she? She's not. You just didn't do the next step. That's on you. Okay? She taught you an easier way. All right? But can you do it by chain rule? Sure. I wouldn't suggest it. Say you forgot that to bring the number front, you could still do this. It's just not so pretty. But up to you. You just have to do more canceling. No, that's not extra marks. That means you didn't listen and do the work. No. So, you did it the harder way instead of doing it the more simple way. No. No. That is not accurate.
Like it's
Not extra mark.
why do you like a smiley face to show how like happy you are?
No.
With ears on it as a reminder to face them.
No.
Smiley face.
Okay. So, we do the derivative of ln y, and we get y prime over y. Shh. Then we get 2 over 1, and then the derivative of ln x is 1 over x ln e. Goes away. Plus 1/2. And then you're going to get 5 over 5x plus 1 ln e. Minus 3 over 1 times 3 over 3x minus 2 ln e. Okay, so we get y prime over y equals 2 over x plus 5 over 2 times 5x plus 1 minus 9 over 3x minus 2. And then what do we have to do? Multiply the y up. So you can bring the y up yourself and then do 2 steps, or you can fill that in right away, which I'm going to do x squared root 5x plus 1 over 3x minus 2 cubed. 2 over x plus 5 over 2. Now they could ask for the tangent line of this. So this is m tangent, but they would have to give you a coordinate. You could just plug it in and get an answer. Like, it's nothing crazy. People are like, I don't know how to do it. I'm like, well, you have a 2 for x. So what you do is you plug the 2 in, boom, m tangent, and then you do point slope form. It's nothing crazier than before. The hardest part is remembering how to do this. Okay, this is the other one that everyone doesn't spot. Okay? So logarithmic differentiation is used for 2 types of questions. The first type is when you have a product rule in your numerator or a product rule in your denominator. We agree? Okay? That's the first type. The second type, which everyone forgets about, and I would star this, is this one. It's where it's a variable base to a variable exponent. Have I ever given you that? No. I've given you a variable base with a numerical exponent and use power rule. Or I've given you a numerical exponent with a variable, or numerical base with a variable exponent, and then you have to rewrite it, log the base, derivative of the exponent, correct? So we've done those two. What we have not done is a variable base to a variable exponent. So that's your second case of logarithmic. It's right under the title here, if you look. See? There's logarithmic differentiation. Here's type 1. And that's when you would do it, logarithmic. And this is type 2. These are the two types you would use logarithmic differentiation for. And this one is when you have a variable base and a variable exponent. Now, if you remember to do logarithmic differentiation, this question is done so quickly. If you don't, you sit there and make up random crap for me, and then it's just not right, and I can't give you any marks, because there's no other way to do it. Okay? So variable base to variable exponent, this is actually done really quickly if you just remember that you have to use logarithmic differentiation. So what's your first step in logarithmic differentiation? Ln both sides. So we're going to get ln y equals ln x to the x. Last time we expanded them out using multiplication and division laws, correct? We just don't have any of those here. We have no multiplication or division, so step 2 is out. We don't even have to do step 2 on this one. Step 3, what do we do? Variable exponent needs to drop in front, and you're going to actually have a product rule. So we're going to have ln y equals x ln x. And if you spot this as a product rule, we just do a product rule of that side. That's it. So what's the derivative of ln y? Y prime over y. And then here we're going to go f and g. So we're going to do f, which is x, times g prime. What's the derivative of ln x? 1 over x. Plus g, which is ln x, times f prime, which is a 1. These are all nice derivatives. So it's f g prime plus g f prime. That's all we're doing. We're doing product rule. Now that first term, the x and the 1 over x, what can we do? Yeah, they get put together and it's a 1. Not a 0. They don't just cancel off and go away. It's 1 plus ln x on that side. So we're going to get y prime over y equals 1 plus ln x. And then what do I have to do last? Bring the y up and replace. So we're going to get y prime equals x to the x, 1 plus ln x. Done. So I'm going to give you till 9:30. Seamus looks sad, so I'm going to give you till 9:20. Oh, even sadder, 9:18. I'm just giving you too much time. You're getting so sad. No, he's not crying. Okay, you have till 9:30 to work on this, and then what we're going to do is we're going to move on to this one here, where we actually have to put a point in, and then we have one little thing left, which is linear approximations, which is one example, and not hard.